All right, guys, so these are the notes for section 12.4. And in this section, we're going to talk about disjoint and overlapping events. And so in order to do that, we have to kind of define what those two things are. Okay, so disjoint events, they're also referred to as mutually exclusive. They are two events that have no no events in common. Okay, so if we're doing like a Venn diagram or something, this would be, these two events, events A and B, would be mutually exclusive, or they would be disjoint because they don't overlap. They don't share any of these that have both quality A and quality B in. Okay, overlapping events would be the opposite. Okay, there are two or more events that have one or more outcomes in common. So at least one. Could be anywhere from one, it could be a million, doesn't matter. They would be overlapping because it would look something like this. They would have some of these that have both A and B in them. Okay, and then a compound event is just the union or the intersection of two events. Okay, so the union would be the whole thing. Okay, all of A and or B. The intersection would just be both A and B. All right, so let's look at example 1. It said a 6-sided die is rolled. Draw a Venn diagram that relates the two events. Then decide whether the events are disjoint or overlapping. Okay, so we're going to use a Venn diagram. Okay, so I'm going to just draw it like this. And it can be as pretty or as ugly as you want it, as long as you can read it. And for part A, the two events we're talking about is the result is an even number. So I'm just going to put even here. You could put A if you want, but I'm going to put even, otherwise I'll forget. And then B if it's prime. Okay, so a 6-sided die is roll. So we're going to have 1 through 6 somewhere on here. Well, guys, I'm telling you, I know it seems awkward, but 1 is not a prime number. It's not considered a prime number for mathematical reasoning far above anything you've had up till yet. You just got to trust me. 1 is not considered a prime number, and it's not even, so we're just going to put 1 outside of both. Okay, well, 2 is prime, and it's even, so we're going to put 2 right there. Okay, 3 is not even, but it is prime. 4 is even and not prime. 5 is prime but not even. And 6 is even but not prime. So our Venn diagram looks something like this. Okay, these would be overlapping. Okay, now I want you to go ahead and draw B on your own, and then decide whether they're disjoint or overlapping. All right, so you should have drawn the Venn diagram and it should have looked like this. You have 6 that's outside of both. 2 and 4, of course, are in the 2 and 4, and then 1, 3, and 5 are in the odd. Now notice there are no events that is in the intersection of these two, and therefore that would mean this is disjoint. All right, so disjoint and overlapping events, we would say the probability of A or B. And we have two different things here. Okay. If the events are overlapping, does it say overlapping here? It doesn't. So this would be if they're overlapping. Okay. And then this down here would be if they're disjoint. Okay. So when they're overlapping, you have this here. Okay. It's probability of A plus the probability of B minus the probability of A and B. We use this because if we don't subtract this, then we would be double counting. We would be double counting the same event. Okay, so if we go back to here, If I didn't subtract 2, I would add it in as an even and as a prime, okay? When in fact, it's both even and prime, so it's just one number. All right, so let's look at example 2. It says a card is randomly selected from a standard deck of 52 playing cards. What is the probability that it is a 10 or a face? Okay, so probability of 10 or face. Okay, so let's let probability of A be the probability that it's a 10, and let's let the probability of B be the probability that it is a face card. Okay, now you have to ask yourself, well, first of all, we want to know the probability of A or B. Okay, so we have to ask ourselves to know which formula we're going to use. Can a card be both a 10 and a face card? If not, this is disjoint. If so, it's going to be overlapping. Well, guys, we can't have a 10 card that's also a face card, so this is disjoint, and therefore we're just going to use the probability of A plus the probability of B. Okay, well, the probability that it's 10, well, guys, there's 4 10s out of the standard 52 cards, one for each suit. And then the probability that's face card, we have Jack, Queen, and King for all 4 suits, which would be 12 out of 52. Okay, so I'm going to substitute 4 out of 52 for probability of A and 12 out of 52 for probability of B, which is equal 16 out of 52, which reduces to 4 out of 13. Okay, now I want you to do part B on your own, and I want you to think through it. Ask yourself, is it disjoint or is it overlapping? And that will tell you which formula to use. All right, so let's go over this. We want to find the probability that we have either a face card or a spade. Okay, so I'm going to let the probability of A be the probability that it's face, probability B be a probability that it's spade. Now, I want to find out, is this disjoint or overlapping? Because depending on which one it is, depends on which formula we use. Okay, so in order to do that, I have to ask myself, can a card be both a face card and a spade? Well, yes, it can, because we have the Jack of Spades, the Queen of Spades, and the King of Spades. So this would be overlapping. And because it's overlapping, we have to use the equation with this in it so we don't double count cards. Okay, so probability of A is the probability that it's a face card, which is 12 over 52. Probability of B is the probability that's a spade, which is 13 over 52. And then minus the probability of A and B. Well, we have these 1, 2, 3 cards that are both. So we're going to subtract 3 over 52. So when we do that, we get 22 out of 52, which reduces to 11 out of 26. All right, I want you to go ahead and do both of these on your own. So ask yourself, is it disjoint or is it overlapping? Depending on which one it is, choose the correct formula, plug it in, get your answer, and then we'll go over these. All right, let's look at part A. So we want to find the probability of selecting an ace or an 8. Okay, so we're going to ask ourselves, can a single card be an ace and an 8? No, it can't. Those are two totally separate numbers. So therefore, it is disjoint. And because it is disjoint, we're going to use this formula. Okay, so probability of A is probability that's an ace is just 4 over 52. We're going to let the probability of B be the probability that it's an 8, which is also 4 out of 52. So when we add those, we get 8 out of 52, which reduces to 2 out of 13. Okay. Now the second part, selecting a 10 or a diamond, this is overlapping, and it's overlapping because we have one card that's both a 10 and a diamond. We have the 10 of diamonds. Okay. So because it's overlapping, we're going to use this formula here. Okay. We have to subtract that one card that's both so we don't overcount it. Okay, so the probability of being a 10 is 4 out of 52. Probability of it being a diamond is 13 out of 52, and the probability of being both a 10 and a diamond is just the 10 out of diamonds, which is 1 out of 52. You add those up, we get 16 out of 52, which reduces to 4 out of 13.